Hey guys, Mrs. Traver here. We're going to do our notes on the quadratic formula and the discriminant. So I've started us up with a reminder on what standard form looks like. That's the ax squared plus bx plus c. And so here's our game plan is we can use this formula, which looks a little crazy. It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. We can use that formula in order to solve for our solutions, our x-intercepts, our roots, our zeros, whatever you want to call them, for this quadratic. So here's the game plan. We will first put our quadratic into standard form. If it's not already, we will then find a, b, and c. And then we will just plug in those values and simplify, and then we will have x by itself right there. So let's look at our first example. We've got x squared plus 4x plus 3 equals 0, which is already in standard form, so that's nice. Then let's find our a, b, and c. Our a is what's in front of x squared, that's 1. Our b is what's in front of x, that's 4. And our c is the number all by itself, that's 3. So now I can just use this formula and plug everything into it. So I've got x equals negative b, so negative 4, plus or minus the square root of b squared, so 4 squared. I'm going to write it out the long way first. I'm not going to simplify anything yet. Minus 4 times a times c. Minus 4 times a times c. And then on the bottom, we have 2a. So on the bottom, we have 2 times a. All right, so the plug-in part is done. And then I hate to break it to you, 1, 2, and 3 are pretty quick. This specific part is what takes the longest, is to simplify. But what's good is that everything that's in here is just essentially order of operations. So on the inside, we're going to simplify that first. Everything inside that parenthesis, that square root. So negative 4 plus or minus the square root of, and let's make this look nicer, 4 squared is 16. Minus 4 times 1 times 3. 4 times 1 is 4, times 3 is 12, so minus 12. All over 2 times 1, which is 2. All right, let's keep going with this. Inside the square root, I can simplify one more time. I'm going to come down here. So negative 4 plus or minus the square root of 4 over 2. One more simplify, the square root of 4 is 2. So I can say negative 4 plus or minus 2 over 2. So now let's actually evaluate our plus or minus, now that the radical's gone. So either I've got negative 4 plus 2 was negative 2 over 2, or I had negative 4 minus 2 is negative 6 over 2, and I can simplify each one of these. This one would have given me a negative 1, and this one would have given me a negative 3. So x equals negative 1 or negative 3. So once we get our formula down, the simplifying is cool from there. Let's do another one. Let's do 2x squared minus 3x equals 5. So first thing to notice here is we are not in standard form. We need everything on the same side to be in standard form. So this 5 is on the wrong side. I'm going to move it to the other side, and when I do, it'll become negative because I essentially subtracted it over. So now I'm in standard form. Let's find our a, our b, and our c. A is 2. It's in front of the x squared. B is negative 3. It's in front of the x. And c is negative 5. Now we can plug in. So we've got x equals negative b, so negative 3 plus or minus the square root of b squared, and b squared, and be careful. When you do b squared, you need to put it in a parentheses. It's not negative 3 squared. It's the quantity of negative 3 squared, so that will matter. And then let's do minus 4 times a times c all over 2 times a. All over 2 times a, which was 2. All right, looks good. Next, let's do some simplifying inside the radical. So negative 3 is just 3 plus or minus. Negative 3 times negative 3 is 9. I've got a minus and a minus. That's going to become a plus. And then I've got 4 times 2 is 8 times 5 is 40. All over 2 times 2, which is 4. All right, inside my radical, that's a 49. So I've got 3 plus or minus the square root of 49 over 4. Square root of 49 is 7. So 3 plus or minus 7 over 4. Let's do our plus and our minus. So 3 plus 7 is 10 over 4. 3 minus 7 is negative 4 over 4. And then one more simplified. 10 over 4 we can make be a 5 halves. And negative 4 over 4 is a negative 1. So I've got x equals 5 halves and negative 1. All right, looks cool. So we can get answers that are normal numbers. We can get answers that are a fraction or number. Remember, these are solutions. So this is where it's touching the graph. So for example, I'll give you a very rough sketch of this graph. For example, would have been going through negative 1 and negative 3. So maybe something like this. It's telling us where it's hitting the graph. Here we've got something at negative 1 and something at 5 halves, which is 2.5. So maybe something like this. But it's telling us where it's hitting the graph. So we know we can hit the graph at a normal number. We know we can hit it at a fraction. We can also get solutions that don't simplify nicely. Notice this one had square root 49. This one had square root 4. We can get ones that that's not the case for as well. So let's look at a problem like that. So we've got x squared equals negative 5x minus 5. So first off, again, this is not in standard form. We need to put it in standard form. So get everything to the same side. Let's add 5x to the other side, and let's add 5 to the other side as well. So x squared plus 5x plus 5 equals 0. All right, and then let's see, find our a, b, and c. So a is 1, b is 5, and c is also 5. All right, and then let's plug in. So x equals negative b, so negative 5, plus or minus the square root of b squared, so 5 squared, minus 4 times a times c, all over 2 times a, so 2 times 1. All right. Inside the radical, I can do some simplifying. So let's get over there. I've got negative 5 plus or minus square root of 5 squared is 25 minus 4 times 1 times 5. So that's 20. So 25 minus 20 all over 2. 25 minus 20, I can make be a 5. So I've got negative 5 plus or minus the square root of 5 over 2. And now if I could simplify this 5 at all, I would, but I can't. So I'm all done. So on the previous problems, we could keep going actually because this radical 5 was something that was a perfect square, and then we had to do the plus and the minus and the simplifying. But if you can't simplify what's in that radical, then you're all done there. So we can also get numbers like this, which it seems kind of funny for me to like show an example of this because like this seems like a far out number, but just to show you, this is a number like any other one. Let's do the plus one. So negative 5 plus the square root of 5 divided by 2. This is about 1.4. And then negative 5 minus the square root of 5 divided by 2 is negative 3.6. So that's over here. So this is truly a quadratic. It's just the fact that the roots were irrational. So we can get rational roots where it hits a regular number or maybe a fraction. And we can also get irrational roots where it hits a number that isn't a perfect fraction. Let's do one more like this before we move on to the last type. Let's do 9x squared minus 6x minus 10 equals 1. So first off, get it in standard form. These ones usually trick people because they think they're in standard form, but it's actually not right now because it's not set equal to 0. So you need to move your 1 to the other side. So I'm going to subtract 1 over. So now I have minus 11 over there. Now it's in standard form because I'm set equal to 0. Now I can say what my A, B, and C are. My A is 9, my B is negative 6, and my C is negative 11. Let's plug in. We've got x equals negative b, so negative negative 6, plus or minus the square root of b squared, and be careful, make sure your b is in parentheses, so negative 6 quantity squared minus 4 times a, which is 9, times c, which is negative 11, all over 2 times a. All right, now let's do some simplifying. Negative negative 6 is 6. Negative 6 times negative 6 is 36. Negative and a negative would make a positive, and then 4 times 9 times 11. 4 times 9 times 11 is 396. All over 2 times 9, so all over 18. All right, cool. Some more simplifying. Inside that radical, 396 plus 36 is 432. So 6 plus or minus the square root of 432 over 18. We need to do some simplifying here. I was pretty darn sure we were all done at this 5 because it was too small of a number. It was prime. But 432 probably has some perfect squares in it. So let's go off to the side and let's factor 432. So over here, let's check out our 432 and find something that goes into it. Maybe I'll just take a stab at the dark. Oh, I took a stab in the dark and 12 goes into it. 12 and 36. You could use anything to start. I just tried something other than 2, so it'll go quicker. 12 is 4 times 3, and 36 is perfect as well. So this is a 6 times 6. That'll pull out. This is a 2 times 2. That'll pull out. So I can pull out a 2 and a 6. So I can pull out a 12, and I can leave in a 3. So I can make this square root of 432 be a 12 root 3. So I'm going to trade that out. We've got 6 plus or minus 12 root 3 over 18. And then the last thing I want to do here is notice the 6, the 12, and the 18. All of those 6 can go in 2. So I'm going to divide all of them by 6 to get my final answer. X equals 1 plus or minus 2 root 3 over 3. So numbers 3 and 4 both were irrational solutions. 4 was a little bit trickier than 3 because I needed to simplify the radical at the end. Let's do one more of these. So number 5, say we had 8a squared plus 6a plus 5 equals 0. Now this one is already in standard form for us, so that's nice. We can jump right to the formula. X equals negative b, so negative 6, plus or minus the square root of b squared, so 36, minus, minus 4 times a times c, all over 2a. All right, let's see. We've got negative 6 plus or minus the square root of, let's do this part. I want to show you too. You can do this part in your calculator, especially if you've got a TI or something that can do a few things at once. Everything inside my parenthesis, my quadratic, everything inside my square root, I can just type it in just as it's written, which will save you some time when you have bigger numbers like this. So I have negative 124 over 16. Now, I know I didn't give myself enough space for this problem, but I actually did. Notice you can't take the square root of a negative. So this isn't just an irrational solution. This is actually not a real solution. This is called a complex solution. So far we've been able to go on the graph and kind of see where our points would be. We didn't do it for this one, but I could do the same on this one and figure out where they'd be. The case with this one, because we can't even take the square root of a negative, let's get an idea of what this graph would look like, because so far all the other ones we've been able to visualize what was happening. If I actually type this in at my graphing calculator, let's see what happens. So I've typed in my original thing into my graphing calculator, and if I graph it, let's see what it does. It looks like it's real tiny up here, like that. So here's the deal. It never touched the x-axis, which is fair game for parabolas to do. So if that's the case, it has solutions, but they're complex or imaginary because they never actually touched the axis. So we've talked about where these things can hit, and so far we've done 2 of the 3. The last one's the quickest. So let's look at the last type of problem. We'll do number 6 and be all done with these notes. So last type, number 6. Number 6, how about x squared minus 4x equals negative 4. So first off, get everything to the same side, so move your 4 over. X squared minus 4x plus 4 equals 0. And then plug it in our equation. So x equals negative b, so negative 4, plus or minus the square root of b squared, so negative 4 quantity squared, minus 4 times a times c, all over 2a. And then simplify. So negative 4 is 4, plus or minus the square root of 16 minus 16, all over 2. So notice something weird here. 16 minus 16, that's going to give us the square root of 0. Square root of 0 is 0. So that's gone. So we've just got 4 over 2, or just 2. So if I thought about what the picture of this looks like, it's as if I just bumped at 2. I didn't actually cross it twice. I just bumped it and only touched once. So in conclusion, we've got 3 different types. Let me show you those 3 types. All right, so I wrote some things in my pause. Here's the 3 different situations. So notice in our quadratic equation, this is what's inside the radical. So that tells us what type of solution we're going to have. If this, what's inside the radical, was greater than 0, so it's positive, then we just get a regular square root. Either the square root's going to work out perfectly and it'll just give us some numbers and it's an integer, or maybe it'll be a rational number where like it went on and on, but irrational, or an irrational number, but it gave us a real answer. So either rational or irrational would work. We noticed in the last couple of problems before on numbers 4 and 5 that we could have gotten an imaginary solution or a complex where the negative was in there. So if this was negative, if b squared minus 4ac was less than 0, then we got 2 complex. And if b squared minus 4ac went away, if it was equal to 0, then we only got 1 answer. That was like number 6. So we'll stop here. I know these were some long notes. Thanks for watching. I will see you guys next time.